Welcome you all in the lecture number 20 of Engineering Mathematics 1 MTL 1025. In this lecture we will going to discuss the reduction formula of sin to the power nx dx, cos to the power nx dx, and third one is sin to the power nx cos to the power mx dx, where mn is greater than or equal to 0. Here n is greater than or equal to 0. Okay, so let us see the reduction formula of sin to the power nx dx. Okay, see, for n is greater than or equal to 2, the reduction formula sin to the power nx dx is equal to this one. Okay, this is the reduction formula. Let us assume let in is equal to integral of sin n x dx. Okay, write it in this form: sin to the power n minus 1x into sin x dx. Okay, integrating it by parts. What is the formula for that? Integral of f g dx is equal to, if we call it first function or second function, you can use your Euler principle. That first function is f integral of g dx minus integral of derivative of first function d by dx of f into integral of second g dx, right, whole integral. Okay, apply this integrating by part formula to this integral, right? See this one here. Then first function is this one and second function is sin x dx. So first function integral of second, that is minus cos x, integral of sin x is minus cos x, minus derivative of first function, derivative of first one is n minus 1 sin to the power n minus 2x, and derivative of first integral of second, right? So n minus 1 sin to the power n minus 1x, and derivative of sin x is cos x, and integral of g, that is sin x, is minus cos x. Okay, so this thing is differential part and this one is the integral of second function, whole integral. Okay, now simplify this term: minus sin to the power n minus 1x cos x plus n minus 1 sin to the power n minus 2x cos square x. Now write this cos square x is 1 minus sin square x. Okay, minus sin to the power n minus 1x cos x plus n minus 1 sin to the power n minus 2x into sin to the power nx dx. Okay, now break this bracket. Okay, see, n minus 1 sin to the power n minus 2x dx minus n minus 1 sin to the power nx. Now see, if we call it in, then what is this? This is in minus 2. It means from this thing in can be written as minus sin to the power n minus 1x cos x plus n minus 1 in minus 2 minus n minus 1 into in, right? Take this thing to left hand side, n minus 1 plus in, that is in. Then in is equal to minus sin to the power n minus 1x cos x divided by n plus n minus 1 divided by n in minus 2. Okay, so this is the reduction formula for in. Okay, this is the reduction formula for not in, sin to the power nx dx, sin to the power nx. Okay, now see, you have to evaluate sine square x, sine cube x, sine 4x, dot so on, right? Sine to the power 5x, sine to the power 6x, sine to the power. No? How you evaluate? You use this reduction formula. Okay. For n is equal to 2, this is equal to minus 1 by 2 sine x cos x n minus 1, that is 2 minus 1 divided by 2, 1 by 2, integral of n is equal to 2, so sine 0, that is 1, 1. So this one is the integral of sine square x. For n is equal to 3, minus 1 by 3 sine to the power 3 minus 1x sine 2x cos x n minus 1, that is 3 minus 1, 2 by 3 sine x dx. What is the integral of sine x? That is cos x. Okay, this thing. Now for n is equal to 4, minus 1 by 4 sine cube x cos x. Okay, 3 by 4 sine square x. Now sine, use the formula of sine square x here. Okay, and simplify it. Got the integral of sine to the power 4x dx. Now see how we evaluate sine cube x cos square x, right? Very simple. Sine cube x cos to the power 4, I can write it 1 minus sine square x. What is this? Cos square x to the power 4 means square it. This is sine cube x and a minus b whole square 1 minus sine to the power 4x, right, minus 2 sine square x. Okay, now multiply it. Then sine cube x plus sine to the power 7x minus 2 sine to the power 5x. Okay, so evaluating this integral means evaluating this one. So evaluating sine cube x cos to the power 4x dx is equivalent to evaluating this integral. And for this integral, we know the reduction formula of sine to the power nx. Use that reduction formula. Okay, see. So this thing is written here, this one. Now evaluate sine cube x, right? What is sine cube x? That is I3. I3 is this one. What is I1? I1 is simply integral of sine x. Okay. Now see, what is integral of sine to the power 5x? Sine to the power 5x, apply this reduction formula. Integral of sine to the power 5x dx is equal to, what is n? N is equal to 5. So minus 1 by 5 sine to the power 4x cos x plus n minus 1, that is 4 divided by 5, in minus 2, I5 minus 2, that is 3. And what is I3? I3 is this one. Put value of I3 is here. Okay, we got I5. Similarly I7. Now put all these values I3, I5, I7 in this equation. Okay, then I3 minus 2 times I5 plus 1 times I7. Simplify this. We got the integral of sine cube x cos to the power 4x dx. Okay, this thing. Now similarly, we can see the formula of cos to the power nx, reduction formula for cos to the power nx is this one. Okay, in similar way. Now summarize this sine and cosine integral in this way. To summarize, we list this as follows. What is mn? What is mn? Mn is greater than or equal to 0, right? And they are integer, and both mn belongs to z. Say this thing n union 0. Okay, this one. In such case, if this type of integral encountered, then in this case we have to write sine to the power mx cos square x to the power k cos x dx, and write it cos square x 1 minus sine square x to the power k, and right, solve this. solve this. How you solve this? Let us assume sin x is equal to t. Then what happens? Cos x dx is equal to dt. Then what is this integral? This integral is converted into the form t to the power m 1 minus t square to the power k cos x dx is dt. Right? Evaluate this integral and replace t by sin x. Okay? This is the first method. And suppose if m is odd number, then what happens? M is equal to 2k plus 1. Then in such case, convert this integral into this form. Write this. Sin square x is 1 minus cos square x to the power k, cos nx and sin x dx. Again, put cos x is equal to t. Then sin x dx is equal to minus dt. Okay. Then this integral is converted into the form 1 minus cos x square, that is t square to the power k. Then t to the power n. Sin x dx is minus dt. Evaluate this integral and replace t by cos x. Okay, we got the result. Okay. Now see the one example. See this one. So apply method B. Since m is 2k plus 1, and what is k? K is equal to 2. 2 into 2 plus 1. Okay. Now write this thing. Sin square x whole square cos square x into sin x. Write sin square x is 1 minus cos square x. 1 minus cos square x whole square cos square x sin x. Now assume cos square x is u. Cos x is u. Then minus sin x dx is equal to du. So sin x dx is equal to minus du. Okay, sin x dx is minus du. So sin square x is 1 minus cos square x and cos x is u. So 1 minus u square whole square into u square minus du. Right? Expand this. Integrate this polynomial with respect to u. Again replace u by cos x. Right? We got the result. Okay. So this is the answer. Okay. In next class we will discuss some more reduction formula of tan to the power nx and cot to the power nx, sec to the power nx and cosec to the power nx. Okay. Thank you.